All right, we're starting chapter 12. So let's talk about sets. So we did a little bit of set notation in Algebra 1. So let me review. What I want you guys to do is I want you filling in your notes completely, following along with me, and pause your video if you need to. Okay? So a set is a collection of objects. Each object is called an element of the set, and we typically use a capital letter to define sets. Okay? If we have no elements in the set, it's called an empty set. You can write no solution kind of symbol right here, null set, or you can actually do the brackets with nothing in them. Okay. Make sure you read this little note over here. A finite set has a specific number of elements. An infinite set does not have a specific number of elements. Okay, so if you look at this, the set of states beginning with the letter O, that's definitely a finite set. Okay, it has a distinct countable amount of states beginning with the letter O. But if you do this set of prime numbers, that's infinite. Okay. All right, so the set of multiples of 4 that are odd, no multiples of 4 are odd. So that's the null set right there. Okay, so let's talk about the universal set, and let's go ahead and read this right here. The universal set contains all possible elements for a certain problem or situation. So the universal set we use as U. Okay, the complement of set A is the set of all elements in the universal set that are not in set A. So it's basically like if you have, well, we'll look at the example right here. Okay, we call it A prime, or we put an A and a bar over top of it. Okay, so this is complement of a set. So if you have the set U is all of these, and the set A is all of these, what would be the complement of A? And I know it's complement of A because it has that A prime mark. So the complement of A would be everything over here that is not over here. So since 4, 10, and 17 are over here, whatever is not 4, 10, and 17, we put as the complement. Okay, so make sure you know what the complement of a set is. Intersection of a set. We already talked about intersections. Okay, so that's overlap. That means it has to be in both A and B if you're talking about set A and set B. Okay, it's actually in both. Okay, so we use that upside down U. But a lot of you, when you were doing that, you made it like that. So you know it's an and statement versus an or statement. Okay, so some people cross that so they remember that it's an and. Okay, that is not the correct way to write it, so don't do that. I just wanted to remind you of what some kids did. Okay, so the intersection of set A and B is denoted A and B right here. So given set A and set B, you have to put what numbers are actually in both. Okay, so that would be 2, 10, and 17. All right, so the union is like an or statement. Okay, ands and ors, like inequalities back in Algebra 1. That means anything in either one works. Okay, so A union B, and it's actually a U, so that makes it easy. Everything that is in A and B has to be listed. So 2 doesn't have to be listed twice, but it has to be listed. Since 4 is over here, we're going to list it. Since 6 is over here, we have to list it. You list everything. Okay, so A union B is anything that ever occurred once. It doesn't matter if it's in both sets or not. All right, so go ahead and take a peek at these Venn diagrams right here. This shows you what a complement would look like if it's a Venn diagram, an intersection, and a union. Okay, so I love how these look right here. This seeing it as a visual, well, okay, so the complement of A is everything that wasn't in A. The intersection of A and B is everything that they share, and the union is everything. Okay, I love this visual for it. So go ahead and pause your video and look at that and color yours in. Okay, so there's a little bit of practice right here. So yours is not filled in. Okay, so right here, if you look at U, the universal set, whole numbers that are at most 8. Okay, so whole numbers that are at most 8 are 0, 1, 2, 3, 4, 5, 6, 7, and 8, right? So 0 through 8. Okay, so at most 8 includes 8. So A is 2, 4, 5, and 7. B is 1, 4, and 7. So if you notice, 4 and 7 overlap. So 2 and 5 are over here, and 1 is over here. 4 and 7 are in the middle. So that means out here, I had to put all the numbers left over in whole numbers that are almost 8 that didn't occur in A and B right there. Okay? So the complement of A, right here, the complement of A is right here. The complement of B, right here. I want you to go through these and see if you understand what we did right here. This is the intersection of A and B. That one's the easiest to see. And the union is all of these right here. Okay, so make sure you go over the complement of A and the complement of B carefully. Okay, so go ahead and pause your video. All right, subsets. So A is a subset of another set if all of its elements are contained in the other set. Okay, so this means right here, this right here would mean that B is a subset of A because everything in B is also in A. Okay, so I just wrote over here, we show it B, and it's kind of like a sideways U with a line. It's not an inequality. Okay, it's like a sideways U with a line. All right, so that's how we show a subset. You may or may not see it this way. It might just ask you to list the elements. Okay, so it may not have you list it this way. Okay, so try to list it this way so you've seen it and you understand the notation. All right, so set A, natural numbers less than 10. So I wrote those all out. Set B, 2, 5, and 9. Is set B or set A, are one of these a subset of the other? Yes, B is a subset of A because B has everything that's in A, okay? All right, set A, all hearts in a deck of cards. So ace, king, queen, there's one set of 13 hearts in a deck of cards. B, all fours in a deck of cards. So these are not subsets because all of the fours are not in the hearts. Okay, so that's a definite no. Number 10, months in the year. B, months that begin with the letter J. Okay, B is definitely a subset of A. So I wrote that over here. Okay, multiples of 10 and multiples of 5. So we have multiples of 5 right here. I could have listed more. Multiples of 10 right here. I could have listed more. Okay, but B is not a subset of A. A is actually a subset of B this time. Hopefully you noticed that. Okay, so I'm going to have you guys go ahead and look at this page. So what I want you to do is cover up the answers. You're getting the answers right now. Okay, look at the Venn diagrams, get the numbers, do the totals from the Venn diagrams, and then check your answers right here. Okay, so I'm going to scroll through so that you can see them all. They're pretty simple, basic adding. So there's through 4. Okay, there's number 5, and there's number 6. Okay, so make sure you do them before you write down the answers and see how you do. All right, good job.